Welcome to the spoken tutorial on simulating a rigorous distillation column in DWSIM. My name is Kannan Moudgalya. In this tutorial, we will carry out a rigorous simulation of a distillation column. We will learn to specify column pressure profile. We will see where to specify tray efficiencies. We will check whether the product compositions are as desired. We will also learn how to view the column profiles. To record this tutorial, I am using DWSIM 3.4. To practice this tutorial, you should know how to open a simulation file in DWSIM, how to add components to a flowsheet, how to select thermodynamic packages, how to add material and energy streams and specify their properties. Our website spokentutorial.org gives details of the prerequisite tutorials. You can access these tutorials and also all the associated files from this site. This slide shows the problem solved in one of the prerequisite tutorials. This was solved using shortcut distillation. Let us open the corresponding file in DWSIM. I have already opened DWSIM. I have already loaded the file shortcut-end.dwxml. This file is available to you for download from our website spokentutorial.org. Let me save this as rigorous. You can see that file name has changed now to rigorous. Click on the Configure Simulation button. Below the Thermodynamics tab, locate Options menu. Let me click it. In the white space above it, you can get an option called Units System. Let me click it. Locate pressure on the right hand column. To see that, let me bring this here. Change its units to atmosphere. Similarly, change the units of delta P also to atmosphere. Change also the units of molar flow rate to kilomoles per hour. Click on Back to Simulation. Let us switch to the slides. The file we opened just now in DWSIM solves the problem in this slide. The solution is given in the next slide. This problem was solved in the spoken tutorial on shortcut distillation. These values form the basis for the rigorous distillation column problem. You may want to write down these values in a piece of paper. We will be using these values shortly. Let us begin by replacing the shortcut column with a rigorous distillation column. Let me go back to the simulation. Press right click on the shortcut column and delete it. Answer yes to the prompt. Locate the distillation column in the object palette. Click on it and drop it in the place of shortcut distillation column. You may have to adjust its position. Click the column and select it. Go to the Selected Object window. Under the Properties tab, locate the Connections menu. It is the third item. In this, we can see Edit Connections. Click on it. Immediately after clicking it, a button appears at the right extreme. A button with 3 dots. Click on it. Now there is a pop-up window. Under the Feeds menu, click on the plus button, which is the Add button. Under Two-Stage column, the option is Condenser by default. Here we have to specify the stage at which the feed enters. Click on the arrow next to the condenser. In my version of DWSIM, I had to click a second time. We can see the list of stages. Select the stage where we want the feed to enter the distillation column. Here we select stage 6. Now we will select the material stream. Click on the down arrow below the stream menu. You may have to click this also twice. Click on feed. We have done the pairing that the feed should go to stage 6. The actual connection will be done later in the flow sheet. This is as per the solution we got in the shortcut distillation column. Let us see it in the slide. We see the optimal feed location to be 6. Let us go back to DWSim. In a similar way, we have to pair the product streams, pair the condenser to distillate, pair the reboiler to bottoms. Now we will connect heat duties to reboiler and condenser. Pair C duty with condenser and R duty with reboiler. We will now convert all the pairing into connections. Click on any one of feed or condenser or reboiler. This completes the connections indicated by pairing. We can move this and check. You can see the connections have been made. Let me close this. Let me shift some streams to make it look more beautiful. Click the column and select it. Under the Properties tab, locate the Column Properties section. It is the first option. This section is used to specify the various attributes of a distillation column. In this section, the first option is condenser pressure. By default, it is 1 atmosphere. We will leave it as it is. Next is the reboiler pressure. I will change its value to 1.1 atmosphere. Using this, I will show how to establish a linear profile in the column. Locate the number of stages option next. You have to enter the total number of trays here. Enter 15 here. Because this number includes the condenser also in DWSim. We plan to use a total condenser. So this number should be one more than the equilibrium stages given by shortcut method. We got the equilibrium stages to be 14 from the shortcut method. We can see it in the slide. Let us go back. The next option is Edit Stages. Click it. Press the button at the right extreme. It shows the condenser and reboiler pressures at 1 and 1.1 atmosphere. These are the values that we entered just now. The new stages that have been added have been assigned 0 pressures, which is incorrect. We would like, in fact, all the intermediate stage pressures to take interpolated values. Go to the left column and click the interpolation symbol at the bottom. Immediately, linearly interpolated values are assigned to every stage. One may also change the pressure in any of the stages 1 through 13. For example, I will click this pressure and change it to 1 atmosphere. Let me undo this by pressing the interpolated values again. This is a very useful and important method. Whenever the number of trays changes, you will have to press the interpolate button. If you forget this, there could be a lot of problems. For example, there could be negative flow rates. Remember to do this in assignment 3 at the end of this tutorial. One may also change the efficiency in one or more stages as given here. Close this pop-up. Next we have the condenser type. For that we have to go up. By default it is total condenser. We will leave it as it is. Next we have condenser pressure drop in atmosphere. By default it is 0. We will leave it as it is. Next we have condenser specifications. Under this menu we have the type as stream ratio by default. Below this, we can see the value menu. Click on the field besides it. Enter the required reflux ratio. Here we enter it as 2. Recall that the minimum reflux ratio from the shortcut distillation was 1.47. By multiplying 1.47 by 1.3 and rounding it off, we get 2. Next we have reboiler specifications. Under this menu, we have the type as product molar flow rate by default. Change the units to kilomole per hour if necessary. We see the value menu. Enter the required molar flow rate. Here we enter it as 61.1. This is suggested by the shortcut solution. We can see it in the slide. Now we will select the solution method. Locate the solving method option from the properties tab. It is item 7. Click on the field besides it. Click on the arrow on the right extreme. We can see a list of solving methods. Select Wang Henke bubble point. Now we will run the simulation. To do this, go to the calculator options. Click on the play button. Now click on the recalculate all button. When the calculations are completed, click the product composition. Choose a stream, for example distillate. You know how to check the product compositions from the molar compositions option. Now click on the distillation column. Under the properties tab, locate the results menu. It is item 8. This shows all the required results like condenser duty, reboiler duty and column profiles. To see the column profiles, click on it. We can see the button appearing on the right extreme. Click on it. Now we can see the pop-up window. We can see the temperature and pressure profiles, flows profiles, component flows and component fractions. If you want to know the exact numbers, use the table tab to the right of the graph tab. Let me close this. Let us save this file. Let me summarize. We learned how to simulate a rigorous distillation column, specified pressure profile, found out where to give tray efficiencies, verify column profiles. Let me give some assignments. Repeat the calculations for a constant column pressure of 1 atmosphere, that is, with reboiler pressure equals 1 atmosphere. Do you see major changes in the results? Next, simulate the distillation column at a constant pressure of 1 atmosphere, that is, the reboiler pressure also is at 1 atmosphere. If the reflux ratio is increased beyond 2, does the purity improve? What reflux ratio should you use if the actual purity is as desired? In a future tutorial, we will show how sensitivity analysis can help do this easily. In the next assignment, we simulate the column at a reflux ratio of 2. Keep the column pressure constant at 1 atmosphere. Increase the total number of trays by 1, that is from 15 to 16. As the number of trays has changed, you have to use the interpolate option. This was mentioned earlier also. With a larger number of trays, has the purity increased? In the next assignment, verify the following relationship. Composition of vapor flow to the condenser equals distillate product composition. Explain why this equation has to be satisfied. In the next assignment, Check the consistency of the variables of the reboiler. Use compositions, temperature and pressure at the reboiler for this purpose. Do this through an equivalent flash calculation. In the last assignment, solve the problem by different solving methods. Compare the results. Compare the computation times. We have come to the end of this tutorial. This video summarizes the spoken tutorial project. If you do not have good bandwidth, you may download and watch it. We conduct workshops using spoken tutorials, give certificates. Please contact us. Do you have questions in this spoken tutorial? Choose the minute and second where you have the question. Explain your question briefly. Someone from the FOSSEE team will answer them. Please visit this site. The FOSSEE team coordinates coding of solved examples of popular books. We give honorarium and certificates for those who do this. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to DWSim. We give honorarium and certificates for those who do this. For more details, please visit this site. Spoken Tutorial and FOSSEE projects are funded by NMEICT, MHRD, Government of India. Thanks for joining.